Happy morning to all and all present here. Here, I would just like to give a small introductory uh, lecture on the usage of FEMM software or FEMM tool in doing electromagnetic theory problems. First, let us just get to know what is the need of a virtual tool for electromagnetic field analysis. Basically, if you just see the electromagnetic theory problems, it will have a complex geometry with a lot of boundary conditions, and it will also get subjected to a lot of real world objects and real world scenarios. So, a virtual tool such as FEMM would just make such kind of complex geometry and a lot of boundary conditions that are being involved with real world objects put into to be made easier. Next, when I just solve such kind of problem analytically, it will lead to a complex way of analyzing. Why? Because if the problem is too complex or it doesn't have any uniform materials inside it or any complex boundary, solving a problem becomes difficult during analytical methods. A virtual tool can handle it easily. And even this virtual tool provides a graphical visualization of this electromagnetic field that makes even the beginners to understand in a better way things like flux lines, potential distribution, the field distributions easily. Now, when we just go on for non-linear materials to be taken into account, this analytical method seems to be too difficult and impossible to get solved at times. But virtual tool handle it easily. Virtual tool can also take into picture the external influences such as eddy current, skin effect, proximity effect while processing that particular problem. Basically, this kind of problem can be just seen in two ways using FEMM software. One is a planar, another one is an axisymmetric problem. What is a planar problem? Basically, FEMM software is used to solve the problem as a 2D problem. The planar problem type uh, using FEMM software is one where we will have only 2D axis plane as X and Y plane, whereas you will not have the symmetry along the Z axis. And this planar type of problem selection is suitable for calculating the field around flat geometry, planar transformers, or any other structures without a rotational symmetry. And next is nothing but the axis symmetry. Axis symmetry is used to model a 3D problem with a symmetrical structure around z-axis also. That is, we just view a 3D problem as a 2D problem in case of FEMM software using the axis symmetry, whereas we will have this in terms of 2D RZ plane, that is radial distance and Z in axial distance. This kind of problem is used for solving the symmetries such as solenoid, coils, circular magnet, cylindrical transformers, something which has a rotational symmetry. Now, what is the importance of using FEMM software is when we just go on for softwares like ANSYS, we can do it as 2D or 3D, but this solving a 3D problem will be just leading to computational complexity. But this 2D will have the same effect or essence that a 3D behavior due to a particular symmetry is being captured will be done using a 2D itself. That also reduces the computation time and computation complexity. Generally, when it is told as a FEMM tool, It is a finite element method analysis tool. Okay, so we want to know what is meant by finite element method. Nowadays, finite element method becomes an integral part in designing each and everything in our day-to-day life. As engineers, we should know in what are the fields this FM is being used. Right from aerospace to the medical, construction, healthcare, and all, we just go on for using the FEM tool, finite element method. Actually, what does this finite element method does? This will be using the mathematical tool to break down a lot of complex problems into a smaller and simpler elements. Then it will be just applying the differential equation to each and every simpler piece or element that is being broken into. Then using the power of the computer mathematics, it will just solve that problem into a linear simple equation that is easy to solve. Actually, finite element analysis has three processes. One is pre-process, then the process that is going on in present, then post-process. In pre-process, we have to define the physics in the real-world condition to be used in a particular model. Once it has been modeled, we have to divide the particular model that has been made into finite elements. That is being told in terms of meshing, in terms of your FEM tool usage. Then you have to use equation to each element, then assemble the equation and then solve them. This takes place in this present process. Then in post process, you have to compute the result to analyze and interpret the implication for the whole domain that has been given in the model. Generally, this finite element analysis tool, that is FEM tool, is used to explore an unlimited scenarios and conditions that has been given in real world problems. Okay, it can be used right from a small square block to a heart, human heart, at any size, taking any physical conditions. Okay, we can just use it. The only thing what you want to know is, as long as you have a differential equation, you can use the finite element analysis method. And what are the advantages of it is it has an access complex geometries, then it can simulate whatever range of physics, then it saves time, money and resources. Generally, while you're just using the FEM tool, what is the procedure to handle any model and get that particular model to be formed into meshes and then find the result, analyze and interpretation. So first we have to create a new model. Okay. After creating the model, we have to define the problem, whether it's a planar and axis symmetry. I have already told you which kind of symmetry can be used for a planar problem and which kind of symmetry can be used for axis symmetry problem. Then you have to go on for drawing the model using the draw tool in FEM. These are the tools that are being used for drawing the model. Then once the model is being completed, you have to place the block labels and assign the block values. For assigning, first we have to go on for adding the material, whether it's a conductor or other material properties. Once the labeling is being done and associated properties to each and every material that is being drawn in the model, we have to create the boundary condition by using this yellow color tool. Then once it has been created, we have to generate the mesh, run and analyze the results. After this video, let us just go on for seeing how a problem is being modeled by using FEM tool. Thank you.